We got cut off a little bit there. Just let me show you real quick. This is the same problem for B, but changes from 20 to 30. So the beautiful thing about doing it in Excel, not StatCrunch, is that if it's in Excel, you can watch, copy, go over here, paste. Okay, there's your next problem. All you have to do is change this number from 20 to 30. And because I used cell references for everything, see the E4, E5, E2, see up here? Those are cell references. Because I did that for everything, everything automatically changed it. Boom, there's the answer for part B. No work at all. So just keep that in mind. Using Excel can come in handy. Another thing to keep in mind is that DDXL will not actually do this problem for you. DDXL only works if you have a column of data. So for this type of problem, you're stuck on your own, either with StatCrunch down here or with Excel. Speaking of DDXL and StatCrunch, all that, let's look at 9.4 number 11. I know I'm not finishing number 9. I'll leave the part C for you to finish your own. But here's a hint, copy and paste, and then change something. Yes? Other than that, it's the same problem. All right, so for number 11, we have this lovely data set here, and they want us to construct an interval. Now, what's different about this problem, so look here at 9. At 9, they want us to do it for sigma squared. See that? That's for the variance. But for number 11, oops, let me go back to it. There it is. Construct a 95% confidence interval for the population standard deviation. That means for sigma, not for sigma squared, but for sigma. That's all right. We can make this work. All right, first thing is first. I have my data in here. Isn't it lovely? Beautiful. Now I need to know a couple things about this data set. So one thing I need to know is what's S squared? That would be equal to, oops, I'm going to have to make this window a little bigger so you can see. S squared would be equal to the variance, VAR, of this data. S, it's a good thing to know. Oopsie, S. I love it when Excel thinks it's smarter. See, it's typing an S, so it thinks it knows you want S squared, so just press the delete key, and then it won't be S squared anymore. That's STDEV, standard deviation, for that data. Let's see, what else do I want to know? I want to know N. N would be count of that data, or you could just count it yourself, right? Highlight it, there's 12 cells, whatever. So there's 12. Might as well figure out degrees of freedom right now. It's N, 12, take away 1. Okay, then the real pièce de résistance, the confidence level. And from the confidence level comes all the rest of the stuff. So let's see, what confidence level do we want? Oopsie, hey, go back down. I double clicked accidentally. All right, so 95% equals 0.95. All right, so then what's alpha? That's 1, take away that. Then alpha over 2 is that value I just found, alpha, divided in half. And then 1 minus alpha divided by 2 would be equal to 1 minus the 0.025. Never forget that these two have got to add up to 1. They always have, even in 9.1. All right, let's find the critical values next. I don't think we'll actually have time to finish the interval here. We'll just do the critical values and then we'll pause. So we need the critical value for alpha over 2, and then we're going to need the critical value for 1 minus alpha over 2. All right, now how do you find critical values? That's the chi-inverse function. So CHI-INV, probability is going to be alpha over 2, comma, degrees of freedom is 11. And then you do it again, CHI-INV, this time 0.975, comma, 11. And again, I'm using cell references. That'll make things easier for changing later on. So always use the cell references if you can. All right, we don't have time to finish it here. I'm going to finish it next time and also show you StatCrunch and DDXL. So see you then.